Good afternoon. Welcome back to the lecture series on design and analysis of algorithm. Today we are going to discuss about binomial coefficient. This is one of the fundamental concepts in mathematics as well as in computer science. So it can be interpreted in multiple ways. Say for example, if you look at the expansion of 1 plus x all raised to n, that series will be having n plus 1 different terms, and the coefficient of x raised to n, that is NCR, the binomial coefficient of n and CR. That is one way of interpreting binomial coefficient. Another way is, if we have n different objects, we want to select r different objects out of this n. Of course, this r should be less than or equal to n. So the different ways of selecting r different objects from n objects, that's again the binomial coefficient NCR. Another one is the number of subsets that can be made out of a set with n elements, with r elements. Number of r element subsets that can be made out of a set of n elements, that's again the binomial coefficient. So there are the mathematical formula, which is the direct formula that can be used to calculate NCR, that is n factorial by r factorial into n minus r factorial. But when it comes to computer science, when it comes to different algorithms, we have a different set of application and usage of binomial coefficient. So we are having two approaches to calculate the binomial coefficient, greedy method and the dynamic method. In the first one, the greedy method, we will be dividing the task of calculating the binomial coefficient NCR into two subtasks, NC n minus 1 r minus 1 and NC n minus 1 r. So to calculate NCR, we need to calculate NC n minus 1 r minus 1 and again NC r minus 1. So these two will be calculated separately and that will be added together to get the value of NCR. This is one way. So here we can expand the calculations in different steps using a binary tree, starting from NCR, that is the root. For example, if it is NC64, so that means n is 6 and r is 4. If you want to calculate the value of NC64, we can subdivide into two parts using the formula NC n minus 1 r minus 1 and NC n minus 1 r. So when it comes to NC n minus 1 r minus 1, r is 4 here, n is 6 here. So n minus 1 is 5 and r minus 1 is 3. So to calculate NC64, first we need to calculate NC53 and then NC54. So to calculate NC54 again, we can apply the same formula. We will be dividing that into two subtasks using the same recursive formula. So this is one way of calculating the binomial coefficient. So here one advantage is we can put this subtask into different child nodes of the binary tree, starting from the root of NCR. Now here the disadvantage is sometimes the same set of calculations have to be repeated. For example, when it comes to NC32, there if you are applying the formula NC21 and NC22. Later on the other branch, when we are coming down for the calculation of NC41 or NC42, there again NC21 will be coming. So the calculations of certain terms have to be repeated multiple times. So this will be affecting the efficiency of the algorithm. So we know that the algorithm efficiency will be calculated in two factors. One is the size of the space taken for storing the different data members, as well as the time needed to complete the entire execution of the algorithm. So that is space complexity and times complexity. Okay. So when the overall process involves multiple calculations which is not required, so definitely it is going to affect the time complexity of the algorithm. So this is one drawback of using this greedy method. Therefore, if you are coming to the dynamic approach of calculating the binomial coefficient, so here we are going to use a table structure. So in the first approach, we have a number of independent subtasks. Why it is independent? Why it is called as independent? One calculation, one task has been completed, the same task may be, or sometimes it will be repeated on a later part of calculations because it is independent. Okay. So now we are coming to the second part, that is the calculation of the binomial coefficient NCR using the dynamic approach. So here we will be maintaining a table, a tabular format, in which the number of columns corresponds to the different sets of values of R, and the number of rows corresponds to the different values of N. So for example, if we have to calculate NC32, so the value of N is 3 and that of R is 2. So starting from 0, there are 3 values for R, 0, 1 and 2. And then for N, starting from 0, there are 4 values for N, 0, 1, 2 and 3. So this will be the labels of the rows and columns of the table. Now we have the basic conditions of the binomial coefficient, that is NCN, that is equal to 1, NC0, that also is equal to 1. For any value of N, NCN will be 1 and NC0 will be equal to 1. So these are the basic conditions, the base condition that will be used to the calculation, and again that will be used as the terminal conditions for the calculations. Right. Now to fill up the values of this table, the last cell of the table will be the cell which contains the answer for the question. For example, if we have to calculate NC32, the last cell will be containing NC32. Alright. So starting from the beginning, we will keep on filling the different cells of the table. So using the basic conditions, we can fill up the first column of the table. The entire cells of the first column can be filled with 1s, because the first cell, if you look at the labels of the first cell, row number is 0, column number is also 0. If you look at the second cell of the first column, the row number is 1 and the column number remains as 0. So if you look at that cell, that will be C10, and similarly the next one will be Z20, the next one will be C30. So since the basic condition we have Cn0 is equal to 1, so we can directly enter the value 1 into these different cells of the table in the first column. And similarly, for binomial coefficient is not defined for a value of R which is greater than N. Therefore, the right upper corner cells cannot be entered the values because it is not valid. The first row number is 0 and the column numbers are 0, 1, 2. So the 0, 0 only we can enter as 1. The remaining 2 columns can be crossed out since it is not a valid calculation. Therefore, we cannot enter any values into those cells. Now coming down, that will be C11. C11 also is 1, we know, because that is also a base condition for any value of n. Cnn is equal to 1. Therefore, C11 is also equal to 1. Now coming down to the next cell, that is the row number 2 and column number 1. So if you look at that cell, the address will be C21. That means there the value contained in that cell will be equal to the binomial coefficient C21. Now if we apply the formula that's subdividing the task into 2 subtasks, if we are applying that formula recursively, in order to calculate C21, we need to apply the formula like Cn-1 R-1 and Cn-1 R. So here n is 2, R is 1. So n-1 R-1 means 1 1, and the second is n-1 R is again 1 1. Therefore, so here the 2 values, that is 1 and 1, the sum of these two values will be the value of this cell C21, and sum of these 2 values is equal to 2. So therefore, the value of that cell is going to be 2. So like that, we can keep on adding or filling the values of the different cells using the values which is already created. This is one of the biggest advantage of the dynamic programming approach to calculate the binomial coefficient. Some of the values which we calculated earlier no need to be calculated. So this is why the cells and the values and the calculations are becoming dependent here. Since it is dependent, when we need to calculate one of the value, if that value or the value which needed to calculate as the subtask that is already calculated means it can be used. So that's why some of the values that's already entered in the table in one of the previous cells will be utilized for the calculation in some of the later steps. Okay. So therefore here the number of calculations will get reduced. So because we are using the previous value, there is dependency on the values of the calculation. Therefore directly the time complexity of this algorithm will be get reduced. So comparing to the greedy approach, timing will be less. So this is a very effective method. So these are the two direct methods to do the calculation of binomial coefficient in computer science. So in the next class we will be coming up with the algorithm, how to implement this by using the Python programming. Thank you very much.